Hey guys, how's it going? In this video we're going to go over 3 worked examples to show you how to do problems involving Newton's second law. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says a 7 kilogram bag of potatoes accelerates down a factory chute at 3 meters per second squared. Calculate the unbalanced force acting on the potatoes. Well, writing down what we know from the question, we're trying to find the unbalanced force F. We know the mass M is 7 kilograms and the acceleration A is 3 meters per second squared. So writing down our equation for Newton's second law, we have F equals ma. Substituting in the numbers gives us 7 times 3, and putting that into your calculator or just doing it in your head gives an answer of 21 newtons. Question 2 says an unbalanced force of 500 newtons acts on a car, causing it to accelerate at 2.5 meters per second squared. Calculate the mass of the car. Well, writing down what we know from the question this time, we're trying to find the mass m. We know the unbalanced force F is 500 newtons and the acceleration A is 2.5 meters per second squared. So writing down our equation for Newton's second law gives us F equals ma. We can then rearrange for the mass m by dividing both sides by A. So we get m equals F over A. Substituting in the numbers gives 500 divided by 2.5, and putting that into your calculator gives you a final answer of 200 kilograms. Lastly, question 3 says a space rocket of mass 2.5 times 10 to the 6 kilograms lifts off from the Earth with a thrust of 3.5 times 10 to the 7 newtons. Part A says draw a free body diagram of the rocket at liftoff. Well, let's say this is the sketch of my rocket, but you can simply just have a rectangle if you want, just a box. And let's label on our forces. Now, our forces are only going to be vertical because there's no horizontal forces at liftoff. So we can say there's a force downwards, which is the weight of the space rocket, and then we've got a force upwards, which is the thrust. So we can call that F thrust, and we're told the value of that is 3.5 times 10 to the 7 newtons. So I've labelled that on, and this is my free body diagram here. Part B then says to calculate the unbalanced force acting on the rocket. Well, to do this, we first need to calculate the weight of the rocket because we only know the thrust force right now. So let's write down what we know from the question. We're trying to find the weight W. We know the mass is 2.5 times 10 to the 6 kilograms and G on Earth is 9.8 newtons per kilogram. So writing down our equation, we have W equals mg. Substituting in the numbers gives us 2.5 times 10 to the 6 times 9.8, and if you put that into your calculator you should get an answer of 2.45 times 10 to the 7 newtons. Now we have the two vertical forces, we're in a position to determine the unbalanced force F acting on the rocket. So we can simply say that the unbalanced force F is equal to the thrust force minus the weight. And we can see that by looking at the free body diagram. We've just found the weight force, which is smaller than the thrust force, so all we need to do to find the overall force going upwards is to subtract the weight from the thrust force. So putting in the numbers now, we have 3.5 times 10 to the 7 minus 2.45 times 10 to the 7, and putting that into your calculator should give you an answer of 1.1 times 10 to the 7 newtons rounded to 1 decimal place. Lastly, part C says to calculate the initial acceleration of the rocket. Well, writing down what we know from the question, we're trying to find A. We know the unbalanced force from part B is 1.1 times 10 to the 7 newtons, and the mass m is 2.5 times 10 to the 6 kilograms. So writing down our equation for Newton's second law, we have F equals ma. Rearranging for the acceleration A, we can divide both sides by m to get A equals F over m. Substituting in the numbers gives 1.1 times 10 to the 7 divided by 2.5 times 10 to the 6. And putting that into your calculator should give you an answer of 4.4 meters per second squared, and the direction is upwards. So remember, acceleration is a vector quantity, so we need a direction. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.